Kom nou. Daar sê hy net vir jou, daar is hierdie krat wat 30 kg weeg. And they tell you that there's an applied force at an angle of 15 degrees and the tension in this rope is equal to 150 Newton. Okay, so hulle sê vir jou, Rudolf sleep 'n krat oor 'n gladde oppervlakte soos in die diagram. Now, the with gladde, you have to know that that means that friction is equal to 0. Okay, so smooth surface or slippery surface or whatever. So daar is dit belangrik dat julle weet, in hierdie geval spesifiek dit sê vir ons, dit is wrywinglose oppervlakte, so dis lekker maklik. Okay, then for the first one they ask you to calculate the acceleration of the crate. So for 1.1, if we draw the free body diagram, they didn't ask you this specifically, but if they don't ask it, always draw it anyway, because it makes it so much easier. So as ons gaan kyk na hierdie is 'n vryliggaam diagram, dan het hy natuurlik sy gewig, and in the opposite direction, it has the normal force. And then this tension, we divide up into its two components. Jy het spanning se y-komponent en spanning se x-komponent. Now, if this wasn't a frictionless surface, you would also draw in friction in the opposite direction. Maar hierdie ene het nie spanning. Ag, het nie wrywing nie. Okay, ek weet of julle nou gesien het, ek het net my kolletjie gaan groter teken, laat al my pyltjies aan hom raak. Dis maar die maklikste manier om dit te doen, want anders te buig al jou pyltjies in. Okay, so when we are looking at acceleration, do you guys agree that acceleration will be on the x-axis? Nee? Hy gaan versnel in terme van die x-as. This box isn't jumping up and down. Okay, met ander woorde, vir my eerste deel van my som, gaan ek net kyk na komponente op die x-as. So I'm only working on the x-axis. And on the x-axis, I can say that F net will only be equal to the x component of t if you choose to the right as positive. As ons wrywing ook gehad het, dan moet jy nou gaan sê minus F ook. Maar ons het nie wrywing nie. Okay. And it would have been negative because it's in the opposite direction of what we chose as positive. Goed, so F net kan ons mos ook gaan skryf as massa maal versnelling. That's Newton's second law, right? F net is equal to m times a. En Tx moet jy nou gaan leer, dit is T wat gelyk is aan 150 maal met cos 15 grade. So op die x-as is dit cos van die hoek, op die y-as is dit sin van die hoek. Okay, and that you just type into your calculator. I'm not actually done with my substitution, so this is 30, A is what I want to calculate, this is 150 cos of 15 degrees, and then you will find divide by 30, that is equal to 4,83 meters per second to the power of -2 to the right. It has to be to the right because I initially chose to the right as positive. Onthou julle hoef nie 'n rigting by te sit as hulle gevra het vir die grootte van die versnelling. So if they ask for the magnitude of acceleration, you don't have to put a direction there. Okay, so that's 1.1. Then for 1.2, they asked you calculate the acceleration again, but this time the surface changes, so now there is actually friction. So I'm just going to add that in here. Hy het nou wel 'n drywingskrag. Want nou vir 1.2 is F net gelyk aan Tx minus F. And before you even start with your calculations, just think about this practically. Do you think acceleration will be more or less when we add friction? Less, right? Because friction is, I almost want to say, slowing it down. Okay, so F net will be smaller. In other words, acceleration will be smaller. So, jy moet vir jouself hierdie checks die hele tyd inbou om te sê, maak my antwoord sin. Die krag het nie verander nie, maar die netto krag het verander. Die massa het nie verander nie, so dan moet die versnelling verander. Okay, so F net is still equal to m times a. This will still be 150 times cos 15 minus 24. mass is 30, acceleration daai is 120,88. I'm not rounding it off now. And then I just divide that by 30. And then acceleration is equal to 4,03 meters per second to the right again. So dit moet vir julle sin maak dat hy nou 'n kleiner een is. Okay. Goed. Nou sê hulle vir ons by 130 bereken die 130, sorry, 1.3 bereken die koëffisiënt van wrywing as die trekkrag verminder word na 150 Newton toe. Now on that, I just quickly want to remind you of a few things. The coefficient of friction, of kinetic friction, is a constant. Nee? Wrywing is nie noodwendig konstant nie. Maar daai ding is 'n konstante. It's a constant because it is specifically for two surfaces. So if it's a wooden box on a cement floor, that is a constant value for a wooden box on a cement floor. Okay. Friction can change. When can friction change? Friction is equal to that thing times the normal force. And of course, normal force can change. Nee? Hoe kan die normaalkrag verander? As ons die hoek waarteen dit getrek word verander of as ons die grootte van die krag verander. So normal force can change, but that thing is a constant for a specific surface. So it can't change. Die ander ding wat hierdie ene, ek dink ek het dit nou gesê, maar daar's twee goed wat die normaalkrag kan verander, dis die hoek en die grootte van die krag. Okay. So I'm going to use this one and say kinetic friction is equal to that thing times the normal force. Die wrywingskrag bly 24. And this, I'm just going to jump back here. So stem julle saam, ons werk nou op die y-as. And on the y-axis, my forces are in equilibrium. So to calculate the normal force on the y-axis, I will say Fg minus Ty. Nee, as ek hierdie ene oorbring, dan word hy mos 'n minus. Because everything pointing upwards must be equal to everything pointing downwards. But I want to isolate the normal force, so then it will be equal to Fg minus the y component. So this will be 24. This is what I want to calculate. Fg is 30 times 9,8. Fy is 100 times sine of 15 degrees. Onthou ons werk nou met sin, want ons werk nou met die y-komponent. Okay, en as die handboek se memo reg is, dan gee dit vir jou. O, jene, wat gaan nou hier aan? (0,09). It doesn't have a unit, it's a coefficient. Okay. Nou vir die volgende ene by 1.4, sê hulle nou vir jou, jy moet hierdie keer die koëffisiënt van statiese wrywing gaan uitwerk. as die trekkrag na 20 Newton verminder en die krat op die punt is om op dieselfde grove oppervlakte te begin beweeg. So remember, this one is another constant, but now it is for static friction, and that can differ on the same surface between kinetic and static friction. Okay, so as hy eers beweeg, dan is sy kinetiese wrywingskoëffisiënt die hele tyd konstant. Okay, maar hierso is hy op die punt om te begin beweeg. So nou gaan ons werk met Fs max, because that is the point where it is almost starting to move. Okay, en as ons op daai punt is, dan beteken dit Tx is presies gelyk aan Fs max. So because they are perfectly equal to one another, they are at the point of almost starting to move. So hulle is nou nog gelyk aan 0, maar as ons 'n klein bietjie meer krag gaan opsit, dan gaan hy begin beweeg. So hierdie ene gaan ons nou kry deur te sê dit is 20, want hulle sê die krag is nou 20, maal met cos 15 grade. So that's what I'm going to substitute in here. And this one will still be equal to Fg minus Ty. But Ty changes now. Nee, hoekom gaan Ti verander? Want dit is nie nou meer 100 Newton nie, dit is 20 Newton. So don't just take your previous values. You have to take the whole new situation into account. Fg won't change in hierdie geval, want die krat weeg nog steeds 30. Okay? But Ty will change. So this one is 20 cos 15 degrees. This is 30 times 9,8, and this is 20 sine 15 degrees. En daai ding is dan gelyk aan 0,067 sonder eenheid.